Hi, it's time for the math easy solution. We're going to discuss further into derivatives of inverse hyperbolic trigonometry, and now look at the derivative of inverse hyperbolic cosecant of x, and basically show that it's equal to negative 1 divided by absolute value of x times it by square root x squared plus 1. And now to prove this, like my other videos, first thing to do is let y equals to inverse hyperbolic cosecant of x right here, and basically this is a inverse function, so this just means we switch the x and y and solve for y. So basically x equals to hyperbolic cosecant of y. So that's all it is, you switch x and y, but now in this inverse function, that's all it means right here. So now what we could do is solve for the derivative of y by using implicit differentiation, but actually before we get to that, this is equal to, by definition, 1 divided by hyperbolic sine of y right here. So before we get the inverse, before we take derivative, I just want to rearrange this. So again, this would equal to x equals to this, and now we rearrange it so we have this on the left side and then this on the right side. So we get we get a hyperbolic sine of y right here is equal to basically 1 divided by x. So now we could take derivative of this. It's a bit easier than before. So we take derivative of both sides. This is basically implicit differentiation. We can take derivative of both sides because both sides equal each other, so the derivatives would equal each other as well because you're taking derivative of basically the same thing. So then the left side here, the derivative of hyperbolic sine is basically hyperbolic cosine of y, but now we have to use chain rule and multiply this by y prime. And y prime, like always, this one is just dy over dx. This is just a derivative. So now this equals to the derivative of this one here. This one we could write this as, actually, I'll keep this, write this further on this side. This is the same thing as writing d over dx of x to the power of negative 1 right here. And now that's the same thing as writing that. So now we could apply using a power rule for derivatives. We could bring this down, and you can see the proof of this in my video links below. So it'll be negative 1. And then this is going to be subtracted by 1, so we're going to have an x2. This is the same thing as 1, basically x to the power of negative 2. So this is the derivative on the right side, is the left side. So if we basically solve for y prime, we get y prime is equal to negative 1 over x squared times it by hyperbolic cosine of y right here. So now we need to basically solve hyperbolic cosine of y in terms of x. So what we could do is use, like always, the hyperbola identity, which is hyperbolic cosine squared minus hyperbolic sine squared is just equals to 1 here. And in this case, we're dealing with y's right here. So now we know this identity. You can see proof of this in the video link below. And now if we solve for hyperbolic cosine of y, we get basically, first of all, we get a cosine squared of y is equal to, move this to the right side, 1 plus hyperbolic sine squared of y. And now what we could do is, square root both sides to get just this by itself. So we get hyperbolic cosine of y is equal to plus or minus square root 1 plus hyperbolic sine of, sine squared of y right here. So now we have a plus or minus, but with the definition of cosine of y, we know that it's equal to e to the y plus e to the negative y over 2. So this one is always greater than 0 right here. You can't make this anything less than 0. You could just even look at this right here. This is going to be always positive. It's always positive as well because it's an exponential function. So then if it's always greater than 0, we can't have a negative. So we only stick to the positive one right here. So basically hyperbolic cosine of y in this case just equals to square root 1 plus hyperbolic sine squared of y. So now that we have this, we could basically plug this into here, and I'll show you why we're doing this in a bit. So we get our y primes equal to, negative 1 over x squared hyperbolic cosine of y. And now this would equal to, when we plug this in, negative 1 divided by x squared, and then square root 1 plus hyperbolic sine squared of y. So we have this one here, but then we could solve for sine squared y in terms of x, because we know that over here x equals to 1 divided by hyperbolic sine of y, so we could write it as Well, we know that x equals to 1 divided by, basically from the beginning of our proof, hyperbolic sine h of y. So if we basically solve for this one right here, move this to the left side and add to the right side, we get hyperbolic sine, like I did this earlier actually. This is equals to 1 divided by x. But now this is squared, so if we square root both sides, square both, so we get basically equals to 1 divided by x squared. So we could plug this in here, so we get y primes equal to negative 1 over x squared. Then this is going to be square root 1 plus now sine squared y, which is this one right here, 1 divided by x squared. So this, we could actually leave it like this as a proof, but usually most calculus books has it like this with this absolute value. I don't really like that, but anyways, I'll show how to get to that. What we could do is times by common denominator on this side. If we multiply this 1 by x squared over x squared, what I mean by that is this 1 divided by x squared square root. This is going to be an x squared over an x squared. That's just equal to 1 plus 1 over x squared. So this is a common denominator, so we could add up like terms. So we get basically y prime is equal to negative 1 over x squared square root. Now the top's going to be x squared plus 1 because we're adding them up, and then the common denominator is x squared. So we have this part, and now what we can do is square root this x squared, so we get negative 1 over basically now we have an x squared here, square root x squared plus 1, all divided by square root x squared if we take it out of this whole square root. And now this one right here, if we square root an x squared, that's just x, except remember x squared is greater than 0. So then, so when we take the square root, the inside has to be greater than 0 as well. So then when we square root x squared, this equals to x, but this has to be greater than 0, so we have to put an absolute value in front. Because we can't have a negative at all because we have this square root overall. So we already know that this x squared is greater than 0. So then it has to be absolute value when we square root this out. Otherwise we'll have an unnecessary negative. So now we have basically y primes equal to negative 1 over x squared divided by absolute value of x. And then this is square root x squared plus 1. And once again, this x squared divided by x, that's just x. Except once again, none of this changes the sign because these are always greater than 0. So we know that x squared over absolute value of x is greater than 0. So when we divide it out, we're going to have an x. But this also has to be greater than 0 because this is overall greater than 0. So, or greater than equal to 0. Let's put that. So we have to put this right here. And also put this greater than equal to 0. Actually, I'll remove that greater than equal to because you are dividing by 0 eventually, so you can't have that in domain anyways. But we're not looking at domain too much. But basically, this has to be greater than 0, so it has to be absolute value of x. And then this would then equal to, I'll write it down right here. Y prime is equal to, well, we know y prime basically derivative of d over dx of hyperbolic or inverse hyperbolic cosecant of x, and this equals to negative 1 divided by, now we have an absolute value of x, times it by square root x squared plus 1. So there's a lot of work here to get to the absolute value, but it's pretty straightforward. Well, anyways, that's all for today. If you enjoyed this video, and yeah, the absolute value, it's pretty straightforward. I have an earlier video on absolute values and their properties in the video link below, so make sure to watch that to get more information on this. But it's pretty straightforward. If you have x squared, if you're dividing by x or absolute value of x, it has to be absolute value because we already know that it can't be less than 0. So anyways, that's all for today. Remember, you can download these exact notes in the Dropbox link below, and also have a bunch of related videos in the video links below in the description, so make sure to watch those for all related videos to this video. And anyways, that's all for today. Hopefully you enjoyed, and stay tuned for another Math Easy solution.